about the conditional probability. We draw a single card from a standard deck, find the probability that the card will be king, the probability of king, the given that is a club, right? That means, so recall, I'm using the conditional probability of an event F given E, which is given by in terms of number of outcomes formula, or you could use the probability of the intersection events, either one. Okay, this is the one I'm going to use. So this is my event F, this is my event E. So let me use the first one because I have the number of outcomes in each card pack. So this is going to be n F intersection E over n of E, right? So what does mean by my numerator? Numerator says that number of outcomes from F intersection E. So you are choosing a card. That card should be king with club. So king with club is only one such a card available out of what? N of E. So the number of outcomes from your event E. My event E is choosing a clubs, right? How many clubs there in my card pack? There are 13 of them.
13.
Yeah. So it is 1 over 13. The next one is now finding the probability of queen given that, which is a face card. So now this is my event F and this is my event E, again using the same formula. So the number of outcomes from F intersection E, you are choosing a card that is a queen with a face. How many such a cards available? Queen with face. Of course, queen is a face card. There are 4 of them. So the event E says that you are choosing a face card out of 52. So how many face cards there? There are 12 face cards. So it is going to be 1/3. Okay. Next one, we are rolling 2 dice. Okay, so when you roll 2 dice, remember we have 36 outcomes. So my sample space is kind of 1, 1, 1, 2, and all the way up to 6, 6, right? So there are 36 of them. So the question is, find the probability that we roll the total that is an even total. So the probability of getting even total. Remember, when you add these two, you will get the total. The minimum total is 2, the maximum is 12. So any number from 2 to 12, including 2 and 12, you have to look for the even number. So the total, which are even, is going to be 2, 4, 6, 8, 10, and 12. Now we are going to look at the outcomes in such a way that you get the total 2, 4, 6, 8, 10, or 12. To get 2, my outcomes would be 1, 1. To get 4, my outcomes would be 2, 2, 1, 3, and 3, 1. To get the total 6, my outcome is 2, 4, 4, 6, 4, 2, 3, 3, 1, 5, and 5, 1, right? To get the total 8, you should have 2, 6, 6, 2, 3, 5, 5, 3, right? And 4, 4. And to get the total 10, you should have 5, 5, 4, 6, and 6, 4. To get the total 12, only one possibility, which is 6, 6. So these are the total possibilities you have when you get the total which are even. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 outcomes. Therefore, the probability of even total is 18 outcomes out of 36. Okay, that is a fact. Okay, so the next one, for a population of a catfish in a certain pond, the probability that a catfish weighs more than 2 pounds is 0.56. This is the probability of having more than 2 pounds. The probability that a catfish is longer than 12 inches is 0.54. The probability that the catfish is both longer than 12 inches and weighs more than 2 pounds is 0.47. So there are three kind of probabilities are given. Okay. So now we are catching a single, the random catfish. And the question is now find the probability of that fish weighing more than 2 pounds given that it is longer than 12 inches. So it is conditionally probability, right? The probability of we are looking for the weight more than 2 pounds given that that fish should be longer than 12 inches. So this is again the conditional probability. This is my event F and this is my event E. Now I'm going to use which formula? I'm going to use the probability related formula because the given information pieces are all about the probabilities, right? So I'm going to use my probability instead of little n. I'm using the probability notation. Okay, ask yourself in words. What is my numerator says? Numerator says that the probability of F intersection E, my event F is more than 2lb and you should have longer than 12 inches of that catfish. Okay, so I need now and event. So if you look at the problem, where is that? Which number says about the and? The last probability, right? The probability that the catfish is both longer than 12 inches and weighs more than 2lb is 0.47. That means this probability is nothing but 0.47 over the probability of E. My event E is what? Longer than 12 inches of the fish, catfish. So where is that? Which one is that? The probability that the catfish is longer than 12 inches is 0.54. Therefore, it is 0.54. Okay, so if you simplify, you will get the exact answer in fraction format, which is 47 over 54. So I'm not rounding up, I'm writing in exact form. Okay. So next one, we are drawing two cards from a standard deck with replacement. Remember, the replacement drawing cards are always going to be independent events. Okay, so you are drawing two cards one by one with replacement. Find the probability. Both of them are face cards. That means what? Question is now finding the probability of both are face cards. That means the first one you are choosing should be face and the second one also face, right? So that's the meaning. So basically this is my event E, this is my event F. Now we need to find the probability of E and F. So remember the formula we have. The probability of E and F is given by just the product of these two events separately. This formula is valid if E and F are what? Independent event, right? So you could go and check your lecture note 6.3. Remember we had one more formula for and that is about the conditional probability formula, right? So this conditional probability with the product, this is true when E and F are not independent. That means independent. But in our case, this problem is about the independence, so I'm using the first formula. So my event is now first is phase and second is phase. So therefore, if you use this formula, that is the probability of first phase, then times the probability of second card also phase. Right? Remember, you are choosing a single card. As I said earlier, you have to treat these two as two different problems, right? So you simply first find out this problem, this probability. You are choosing a card. That card should be a phase card. Remember, there are 12 phase cards out of 52. So second time, again you are replacing the card. Therefore, again you will have 52 and same outcome. So it is 12 over 52. So simplify this one. What is the answer? If you simplify, I believe 9 over 169. Could you check? You have two dice at a time. You are rolling two times. Do you understand the
so
question?
12?
You see now. Okay, you look at like this. You have two dice, right? This is my first die and second die, right? So here you have six outcomes. Here you six outcomes. So you just imagine you have two dice at a time in both hands. You are rolling twice. That means basically you are rolling each die as two times. Does that make sense? That means in total you are drawing four times altogether, all two dice.
Right.
Does that make sense, Melissa?
Yes, it does.
Okay, that means where's my outcome? 6 times 6 times 6 times 6, right?
72.
Yeah.
Does that make sense?
Mm-hmm.
That means, for example, one of my outcome is like this: 1, 1, 1, 1. What does mean by that? That means these two numbers coming from your first rolling with the two dice, right?
Right.
These two numbers coming from your second time, rolling with the two dice. Does that make sense? So
Yes.
this is my first die, this is my second die, right? But this is first time drawing. This is my first die, this is my second die, this is for my second time drawing. Is that okay?
Yes.
Okay. Now question is, if you add these two numbers for my first drawing, 1 plus 1 is 2. Here also 2, right? This particular outcome says what? Both of them are total 2. Does that make sense?
Yes.
Like that now, the question is find the probability that both of them are what?
10.
10. That means what? That means one of those is like this. 5, 5. Okay?
Yes.
Then 4, 6. When you add this, getting 10. When you add this, getting 10. So both of them are 10. Does that make sense?
Yes.
Okay,
Yeah.
like that, how many possibilities I could write here? Let's see who's telling.
2.
No, you have more than that.
Yes, that's right.
If you are very smart, you could use the previous answer I have drawn here. Look at okay, let me choose a different color. Okay, look at the previous problem we had, getting total 10 for two dice, right?
Right.
That means this is only one case. This is only for the one case. You will have 5, 5, 4, 6, 6, 4. This side also you will have the same number of chances. So 3 times 3, which is
9.
9 outcomes. Very good. So what are those? This is one of those, right? Okay, so let us write down all the 9 outcomes. Okay, let me write down. You may have first row 5, 5, but second one may be 6, 4. Right?
Mm-hmm.
And look at here. And you may have here 4, 6, right?
Mm-hmm.
And here also you may have, go ahead, 4, 6, right? I could include one more here, 5, 5 and 5, 5 as well, right?
Mm-hmm.
This is also possible, right?
Yes.
And the 4, 6, 6, 4, possible, right?
Mm-hmm.
And 4, 6, 5, 5, possible, right?
Yes.
What else? 6, 4, 6, 4,
Mm-hmm.
possible, right?
Yeah.
And 6, 4, 4, 6, possible, right?
Mm-hmm.
And the last one, 6, 4, what is that? 5,
16.
5, 5, 5.
Oh, 5, 5. Yeah, 16.
So now you should have a 9.
Oh,
1,
we did
2,
5, 5 already up top.
where? Oh, yeah, you're correct. Oh, no. That is different, right?
Oh, that's different?
That is the first die is 5, 5. And this one is second die is 5, 5.
Looks like 5, 5 in both rows.
Where? I don't have 5, 5 in both rows. 1, 2, 3, 4, 5, 6, 7, 8, 9. All 9 answers are different answers, all right?
Uh-huh.
Which one you are seeing the same one, RB? I don't see any same one.
The third one down. 1, 2, 3.
Which one?
Count from like right. Can you see that?
This is my answer.
The 4, 6, 4, 6, you say?
Like, come on down. Like 1, 2, 3, 4. Fourth row.
Okay. This is 5, 5, 5, 5.
Uh-huh. And then you
Okay.
got 5, 5, 5 at the end.
The end is 6, 4, 5, 5, right?
At the very end?
Yeah, that is 6, 4, 5, 5. Different one, right?
Okay.
Is it correct, Melissa? All 9 are different, right?
Yeah, that's right. They are.
Yeah. All 9 are different, RB. You 9 different combinations I have now, in another word.
I see it now.
Oh, yeah, very good. So, but remember, as I said earlier, you will have in total 6 times 6 times 6 times 6, which is, what is that number? Is that 1296?
Yeah, 1296.
Oh, yeah, you will have 1296 different combinations, right? There are plenty, no, of course, right?
Yeah.
So I have only this much of, outcomes. So there is 9 outcomes. Therefore, what is my answer? The probability of getting both tens. It is 9 possibilities out of
9.
12 nines.
Yeah.
12 nines. Yeah. So what is that number?
1/4. 1/144.
Okay, very good. Okay, makes sense. You understand this question? Kind of thinking, yeah. Okay. Right. So now let's move to the next one. We are drawing 2 cards from the standard card with replacement. Oh, this question is similar to the one I did, right?
Yes.
Yeah. So I think I just I'm leaving this problem. Okay. I believe you could do that, right? So just let me write the first step. So both our queens mean what? The first queen and second queen. So use the product formula. Okay. This is similar to which problem? Oh,
First.
I left one part here, right? Part B from number 4. Did I do that? No, right?
No, you didn't do that one.
Yeah. So just I'm writing here that answer. Okay. So what was that? The part B was finding, the probability of none of them are face cards. You are choosing 2 one by one with replacement. That means the first card is no face, and the second one also no face. That means this is my event E, this is my event F. So simply just the product first, no face, times the probability of second, no face. So remember, you are choosing one card. What is the probability of having no face? There are 12 face cards. The remaining from 52 are no face. That means 52 minus 12, which is 40, right? 40 are no face out of 52.
10, 13.
Yeah, what is that?
Oh, hold on.
Yeah, 100 over 169, right?
Yes.
Okay. All right. So therefore, they use that formula. So you figure out that. But here, what is that? Okay. Now here you are drawing jack after queen, right? That means the first is queen, right?
Mm-hmm.
And the second one is jack. Again, this is event E, this is event F. Again, use the product formula and just find the the probability. So the probability of E, probability of choosing queen, there are 4 out of 52.
Mm-hmm.
And the second time choosing jack, how many jacks there?
4.
Again, 4 jacks, right?
Yes.
Yeah. So that should be 1 over 169. Okay. Okay.
Now, did we have homework at the end of this section?
These all homework problems.
Okay.
I'm just, doing the homework assignments problems because I told you earlier, right? You don't need to turn in now.
Okay.
So this all I'm doing your homework assignments, and I'm going to pick some problems from this for your test, right?
Okay.
Um,
Gotta have the one in Newton done, right?
Say it again.
The one in Newton.
Oh, that you have to do. Yeah. Okay. Anyway, I'm going to reopen all the Newton assignments this weekend. Okay. I will post announcement in. Here we go. Okay, so this is the last problem about the probability, conditional probability. The following table gives the ages of employees of a certain company. If you randomly pick an employee, find the probability that, so you are picking a person, right, with this chat. The question is now, find the probability of choosing a male, given that that person is the age between 20 to 29. Again, this is conditional probability, F and E. So you are given a number of persons. Therefore, I'm using number of formula. Okay. So now ask yourself, what does mean by my numerator here? Numerator says that the number of outcomes from the event F intersection E, the overlap event. So my event F is the male. At the same time, that person should be between 20 to 29, but male, right? Should satisfy both. So I'm looking for age 20 to 29, but that should be a male. So it is going to be 8, right? So there are 8 persons. That is my numerator. Over the denominator is just an event E. My event E is what? You are choosing a person, right? The age should be 20 to 29. So how many persons are there between this range, 20 to 29? Now you are looking for the persons, maybe male, maybe female, but only you are looking for the range of the age. Therefore, you have to look for this total now. Does that make sense? Remember, I told you earlier, you have to treat these two like a separate problems. Don't mix them, okay? So this is just an event E. If you look at event E, they don't talk about any, male or female. They talk about only the age. Therefore, you have to look for the only age and ask yourself, how many people are there with this range? Just 18 of them. Okay. Now simplify this. It's going to be 4 over 9, no? That makes sense?
Yes.
Okay. Now next one. The probability of choose person is from 30 to 39 years of age, but that person should be a female. This is my F event and this is E. Again F intersection E over E. So now remember, you are choosing a person to satisfy these two now. Should be female, be 30 to 39. How many of them are there? 13 to 39, female.
20.
20. over NE. E is what? Simply you are choosing a female.
39.
38.
I mean 38.
Yes. So that is, could you simplify? What is that? 10 over 19, right?
Yeah, that's
Okay, good. Okay, so hereafter all the problems are coming from statistics, chapter 7.1 and 2. The first problem is very much easy. You are given a bar graph to plan the budget for the next fiscal year. The campus tutoring center surveyed the number of students using the center hourly between 9 p.m. to midnight for a particular semester, right? Okay, you have to understand the units carefully. My x-axis is the number of students. What is my y-axis then? Number of hours. So we are looking for, the number of students they spend, how many hours. So they just check, right? Randomly they are going, right, into the tutoring center, sitting for some hours, certain hours. For example, if you look at this bar, what does mean by this bar says? This bar says, what is the height of this bar? 3, right? This number is 3, no? That means what? Survey people, they are going and sitting for 3 hours and checking how many students are coming between that 3 hours period. So how many of them are there? 4 of them. Like that, they are, collecting the data. So make sure that you understand the units, okay? So number of hours versus the number of students. Okay. So let me find first all the bars, the blocks heights. So I'm going to find, okay? Could you tell me what is the height of my first block here? This is 7, right? So next one is 8. This height is 5. This is 3. This height is again 8. And this height is 10. And the next one is again 7. And this one is 9. This one is 5. This one is 3. And the last one is 2, right? These all hours, 7 hours, 8 hours, 5 hours. Here nothing is so off. That means in that hours, no, I could say they don't have the data values for 3. Okay. So this is the picture. Now look at the first problem. What was the smallest number of students in the tutoring center, and how many times did it occur? So how many times mean they are talking about the hours? Okay. So if you look at the number of students, the smallest possible value is what? 0. But how many times did it happen? It happened 7 times. Frequency means number of times. That means for 7 hours, no one show up, right? Therefore, 0 and 7. What was the smallest student count between 5 and 8? Okay. Inclusive means you are including 5 and 8. So I'm looking at what was the smallest student count between 5 and 8, right? Okay, so 5 is here, 8 is here, but 5 and 8 are included. So from 5 to 8, which bar has the lowest number from 5 to 8? Look at the height of the bar. The third bar has, the lowest height, right? That means, you see, the smallest student count is now 7. How many hours students were there? 7 hours. Okay. So it happened 7 times. Okay. Okay, the next one. For how many hours was the survey taken? Let's see who's telling. What do you want to do? Simply add all the possible hours. That's what I have found all the height bars. The height of the bars are simply the number of hours. So if you add all the height of the bars, it will be given the total number of hours you made the survey. So answer is simply add all the heights of the bars. So that is 7 plus, 8 plus, 5 plus, 0 plus, 3 plus, 8 plus, 10 plus, 7 plus, 9 plus, 5 plus, again 0 plus 3 plus 2.
63.
63. Very good. So this is the total number of hours they made the survey. Okay. So the next part, among these 63 hours, for what fractional part of the total number of hours were fewer than 5 students present? So you are counting how many hours I had for fewer than 5 students. So fewer than 5 students means which bars, corresponding bars. 5 is here. So fewer than 5 is from 0 to 4, right? This range. Simply add all the corresponding height of the bars, hours. So that is 7853, right? 7853
23.
out of the total number is 63. Yes, what is that? 23. Oh, wait, is that 63 or 67? Are we?
Oh, I think it's 67.
Yeah, I remember this problem. 67. Sorry for that. So it's
23 over 67.
yeah. By looking at the answer, I remember. Okay, so that is 23 over 67. Can we simplify further? We can't because my numerator is a prime number, so you cannot simplify further. Okay. Oh, now this one. Remember last time I told you how to find mean? So you could do this problem manually or you could use the calculator. That is up to you. So remember, the finding mean, we had the formula x bar for mean. That is the summation of x over n. That means you add simply all the data values. That is my x. Then divide by number of data values. So that is 25 plus 23 plus 27 plus 22 plus 26. Then divide by how many data values? 1, 2, 3, 4, 5. And find the answer for one decimal place.
24.6.
Okay. Say it again.
24.6.
Okay, this is one way, but you could use the calculator. Did I show you last time? Yes. You know how to use the calculator to find the data outcomes. Last time I explained about the 5-number summary. Do you remember? Yeah, that's the same procedure here as well. So you have to go and enter all the data values into, you need to feed the data values into your calculator. So go to stat and edit, number 1. Okay, let me clear these all. Okay, I'm going to enter all the data values, 25, 23, 27, 22, and 26, right? These are my data values. That's it. Then go to stat again. And now second option, calculation. Then number 1 var stat. Okay. So go to 1 var stat. So it will give you the answer. Enter. One more time. Oh, you see now X bar. This is my mean, 24.6. We got that answer, right? Is that okay?
Okay, do that again. Go to that step again.
Okay. This
Stat. Then we put the numbers in.
edit.
Edit.
So enter. Into L1, right? Then again go to stats. Then now calculate.
Okay.
Then number one was stats. Oops. Then plus enter.
Got it.
Then where's my mean answer? Mean answer is x bar. Okay? Good. Okay, but remember I explained about the table. If you are given a table, right, with the data values and the frequency, then which formula we use to find the mean? Now you have one formula for mean for the table. X bar is given by the summation of f times x over the summation of f, right? Remember, summation means the total. So that means you need to create one more column here to find what? F times x. So f is my frequency and the x are my data values. Simply just multiply these two out and put the values here, right?
Right.
Okay, so take your calculator and multiply these two numbers and put. So 52 times 4. 4 times 2 is 8. 208. So this is 318. This is 162. And this is 440. And this is 224. And this is 171, right? All right.
Yes.
Now find the summation f and find the summation fx. Summation f is simply add all the frequencies, how much you have, 10, 13, 21, 25, 28, right? Now add these numbers. When you add the I don't know, is that correct? Should be correct, right? Melissa?
Yes, it is.
Yeah. So I got two numbers plugging here. The summation fx is now 1523 over summation f is 28. So then what is that? So that says 54.4. Okay, so that is my mean. Doesn't matter. Again, you could use the calculator for the, for the table. Okay, so now unlike the previous problem, in previous problem you had only data values, right? So you entered all into L1 column. Now you have two columns, right? Data values in one column and frequencies in another column. Therefore, you need to use two columns now. So go to stat, okay? Go to edit. Now enter your data values into two columns. My first L1 column is X and my L2 column is frequency. Okay, then again go to stat, go to calc. Now since you have two column, you have to go for the second one, two var stat, then press enter. Okay, so we will do that. So I'm going to enter these all the data into let me clear that. So my L1 is all the X 52 to 57, 52, 53, 54, 55, 56, and 57. And my L2 column is all frequency 4634, 638, and 43. Okay. Then go to stat again, calc, number 2 now, because you have 2 columns, enter. Very close, right? I'm getting that answer.
Yes.
Good.
54.5.
Okay, so very close. Only 1 decimal is different. Doesn't matter. That is not big deal, right? 54.5 and 54.4. Okay. Okay, that is there. So the remaining parts are going to be easy for you guys. So we discussed last time. Okay, you all know how to find a median, right?
Yes.
Do I need to do that? I don't think. So arrange the data and find the mid number, or use the calculator, enter all the data into L1 and find the the summary, and you will find their median. Median means which letter we use. What is the notation we use for median?
Oh,
Under the 5-number summary?
I forgot.
Yes, which is Q2, right?
Q2. Yes, Q2.
Yeah. So enter all the data, all the data values, then find the summary. Okay. Do I need to do that?
You can go over it one more time.
Okay. So I'm just entering all the data values. Okay. So go to stat, edit. Okay. Let me clear first. So I'm going to enter all the data values. So 42, 51, and 56, 55, 56, 55, 51, 54, 51, 60, 54, 51, 60, 61, 43, 55, 61, 43, 55, 56, 61, 52, 56, 61, 52, 69, 64, 46, 69, 64, and 46. So make sure that we enter all the data values. You should have 17 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Yes. So after that, make sure that you enter the correct values, all 2 digits number. Yes, I'm good, right?
Yes.
Okay, that's it. Go to stat, calc. Now you have only 1 column, right? 1 bar. What's this? Oh. The same answer, right? Like earlier, the same answer, 54.5.
Mm.
That is mean, right? We are looking, oh, now we are looking for the median. Where's median? That is 55, right? Is that okay? Okay, right? So here, number 12, there's a typo here. We need to use the exercise number 11, the previous problem. They are basically telling that to use the previous, number 11 problem to, draw the box plot. So could you change that to 11? Problem number 11. Okay, so last time I explained about using calculator for drawing box plots. Or if you want, you could do the manual way. How? Find all 5-number summary and denote all, mark all the 5 values here and draw the box with Q1 to Q3. then identify max and min and draw the box plot, okay? But now, since I have calculated, entered all the data values for the same problem, let me, use the calculator. Remember, first we need to check the window. So my minimum value is 42 and the maximum is 69. So I need to cover those two values in your display. So I'm making 40 to 70 for my display. So 40 to 70, I'm making minimum is 40 and the maximum is 70 to cover all the values. And scale I'm leaving 5. This all I'm keeping like a default one. Only you used to change, first three values, x min, x max, and scale. Okay. Yeah, this is the Windows setup gone. So let me exit from this. Okay, what else we need? Now we need to go to the stat plot and make sure that everything is good. Yes, I'm going to choose plot number 1. Enter there, and the type I'm choosing for number 4 because I'm drawing box plot. Okay, so I entered all the data values into L1 column. That's fine. The frequency default is 1. Leave that. That's it. So now quit. That's it. Then graph it. So this is my box plot. So you could copy down your picture here. This side, the right side is having little bit lengthy, right? Lengthier than the left side. So make sure that you are putting all the values. How do you find the values on your box plot? Simply just press the trace button, trace it, and if you trace over, your picture, and you will find all 5 numbers, right? Minimum is 42, maximum 51. Sorry, Q1 51, median 55, Q3 60.5, and the maximum 69. So you could copy down your picture after drawing there and simply just copy down. So picture says that the right side is a little bit smaller, bigger than the left side, and what about the wings? So wings are kind of similar, right? Both sides. But anyway, you need to write down all 5 numbers somewhere here, okay? Write all the 5 numbers. Minimum Q1, median is my Q2, and Q3, and the max. Minimum 42, and the Q1. How much we got Q1? So we got Q1 is 51. So that means this is my minimum. Q1. Okay, so this is my box plot. Okay then, so we are in last problem. Oh, finding mod. Which number repeats most? Yes, 9, right? Is that correct?
Yes.
Yes. What about here? Guys,
Yeah, I see.
do you have any number in such a way that compared to other numbers having more frequency?
No.
No.
No, you don't find such a number. I explained last time. If you have same frequency for all the numbers, then answer is
0.
There is no mode.
No mode,
You
yes.
have to write in words.
There's no mode.